up, dude? Specifically, this dude. Actually, I mean dude in, like, not necessarily a guy, but I mean, like, dude as in, no, not dudette. Dudette is in, like, the 1700 definition where I was talking about a fashion-forward thinker. That's the actual Scottish definition, so that's why I call her dude. Anyway, let's get this party started. So here's what I got. I've got solids, liquids, and gas. And what we're going to be doing is we're going to do an investigation to see how water moves through the different types of materials. Got it? So I have my controls. Are all of my beakers the same size? Yes, absolutely. Do I have the same amount of stuff in each of them? Yes. You got to say it out loud.
Yes.
Yes, good. Then that's a part of your controls. You want to keep those things the same. Do I have the same, like, thickness
Yes.
of beaker? All right, good. What am I changing in each of these? What's different about this one and this one and this one?
This one's the rocks, which has more holes.
Okay, there's more holes. I can actually see through the thing almost a little bit. All right, and then this one?
This one is tons of little, like, it's sand.
It's
so
sand.
Yeah, and that's clay.
And that's clay. Okay, so what we're going to do is, that's what our independent variable is. We're changing one thing about each of these things. We're changing the size of the particles of stuff in there. Does that make sense?
Mm-hmm.
All right. That would be our independent variable. What is our dependent variable?
The liquid.
The liquid. No. It's the same liquid for each of them. What is it that we're measuring in the end?
To see which, in A, B, or C, see which one the water gets to the bottom.
Water gets to the bottom first, so I would be measuring what?
Speed.
The speed or the time. So the time depends on the type of material. That's why the type of material is your independent variable, but your dependent variable is the time. Got it?
You have to take this out.
How does this work? Oh, yeah. There we go. Awesome. All right. Mode. Oh, there's the stop. There's the reset. Got it. You know how this works?
Yes.
Good.
Start and reset.
All right. So here's what we're going to do. We've set up our experiment. We have the same amount of stuff. We didn't want to change that. And I'll tell you what. We'll make a D column.
With what in it?
The D will have this. You get to make up whatever it is you want.
Somebody has a couple rocks and clay in it.
It's got some sand and clay, or some gravel and clay. What else do you want to put in it?
Maybe some sand.
More sand? All right, go for it. It needs to be, you can add 3 more scoops, right, of this thing?
Mm-hmm. But for the gravel, there's only 1 scoop in there.
Okay. I need to get a tape or a measuring stick.
So we can do 3 scoops per each one.
Well, no, you can't do any more, right? Because it's got to be the same height.
Yeah.
So, option D will have a mixture of all 3 of them.
Yeah.
There's 1 scoop of gravel. There's 3 scoops of clay.
And 3 scoops.
And there's 3 scoops of sand.
Yeah.
So technically, D has a little bit more than everybody else. I don't think that's cool. I think we should probably even it out. Everyone should have 7 scoops then. All right, so let's put 1 scoop of each into each one. Let's start off with the gravel. Do the gravel first. Sorry, we're still getting this experiment set up. I don't know why we use the funnel, but whatever. For the gravel. Got it.
Are you sure this is clay? It looks like powder.
This is actually, I'm not an artist, so I mean, yeah, it is clay. It's a type of clay. All right, cool. So here's what we're going to do. In your lab, you're going to have to write in the types of things you have. So over here, we put in A, we have clay. In B, we have sand. In C, we got gravel or rocks. And in D, we have a mixture of all of them. And you can even put in what you think. All right, so here's my question for you. Rank these in order. Which one do you think will be the fastest and which one will be the slowest?
I think this one will be the rock.
Okay, we'll go back to this.
Yeah.
There we go. All right, go.
I think C will be the fastest.
Got it.
And the slowest.
Yeah.
I think this one, D, because it has a mixture of all of them.
Okay. What about the second fastest?
Second fastest, clay.
So you think fastest? So if I were to give them numbers, this would be 1.
And then that would.
Oh,
yeah,
you think this is 2?
Yeah, that's what I meant.
Sand.
Yeah, and then that would go there.
And this is.
Yeah.
Why? All right. So we're making a hypothesis at this point.
Yeah. So
our
think
hypothesis. This is our prediction. And why? Why? I'm just curious to know.
I think D will be the fastest because D has a mixture of all of them. So.
Oh, this guy will be the fastest.
Yeah, fast.
Faster than this.
I mean, slowest.
Slowest. It's all right. You think he'll be the slowest?
Yes.
Okay.
And then that'll, because it has a mixture of sand, clay, and gravel.
Okay.
So, and the clay and the sand will make it go a little slower.
Cool. Let's talk about these 3 though.
Okay.
Why do you think this one's going to be the fastest?
Because there are tons of holes in between all the gravel.
And by holes, you mean there's little
Spaces, yeah.
Okay. So the water can kind of
go
through, and then over here.
Because their sand is like mini rocks, like really tiny rocks.
Mhm.
It can go through a little faster.
Got it. And then the clay.
It's a thicker substance.
Yeah.
So
If you feel it, what does it feel like?
it feels like it feels. I don't know.
It feels like baby powder.
Yeah.
I don't know if you've or have experienced baby powder, but that's what it feels like to me. Okay. So here's what we're gonna do. Let's predict some times. In fact, why don't you write in this information? You got a pen?
No, I do not.
All right, let me grab a pen. There you go. So you want to put in your, skip the materials, we already can do that. Rank them for me and then predict the time for me.
Okay, so material, no need. And then predicted rank
Yeah.
would be
C will be 1.
1.
That's what you're thinking.
Right here?
Right here.
1, and then B would be
2.
2.
A is 3. That's what you're saying.
Yeah.
Now this is what Maya specifically is saying, but it's not necessarily what everybody else has.
And then D would be 4.
And she thinks D would be 4. Okay, hey, that's a good prediction. Let's try to work it out.
And then we would have to do
Let's predict the time. How long do you think C will take?
that.
Give me seconds. 10 seconds.
I think around 7 or 6 seconds.
6 seconds. Good. What about B?
Say around 10.
10. Okay. What about C? I mean A.
12 or 14. No, 13 or 14.
Okay, write it down. You said
So
6, 10, and 14.
I wrote it wrong. Okay. C is 6.
C is 6. Yes.
B is 10.
B is 10.
A is 13.
13.
D
And D.
is about, let's say 14.
14.
Yeah.
Okay. Here's what I'm going to do. I'm going to put a cup over here, or a funnel. We'll get a little test tube right here, and I'll let you do this. Let's take exactly 10 milliliters of water. And by the way, this is just food coloring in water. Okay, so it's still water. I just put food coloring there. That's so you can see it. And I'll put this thing up over here so you can see maybe the lab a little bit better. Is that easier to see now on the video screen?
Yeah. It looks
All right. So what I want you to do is pour it in, and I want you to time it. Or do you want me to pour
Yeah.
and you time?
Yeah.
All right. So you tell me when, and I need you to yell out "start" and "stop."
Okay.
So that way those online can also time it as well. All right. Ready?
Okay, ready, set, start. Stop.
Okay. How long did that take you?
1 second.
1 second. Write that down.
It's completely different. 1.85.
Well, it's fine if what we experiment is completely different.
Yeah.
I mean, not completely different, but it's fine. I mean, it's an experiment. That's what you do. All right. How much did we use? 10 milliliters.
10 milliliters. Reset.
Actually, to be honest with you, I'm not sure if this is milliliters, but I do know that it's all the same.
Yeah.
And one of the things I forgot to do, and we can kind of still do this right now, is maybe I should measure for you the height at which the thing is at. They're all about 6. They're all at 6 centimeters.
It looks like 7.
Okay, right. This one is at 7 centimeters. This one is at 6 centimeters. Clay is at 7 centimeters. And this one is at 6 centimeters. Okay. All right, so we're timing for B. I'll just have this thing over here so you can see the B really well. All right, so ready? Okay, we'll put it up front so you can see it. Tell me when.
3, 2, 1, start.
You ready? Is it going through? Can you see it? It's on this side over here. Keep it going.
Wow, it's already at 13 seconds.
Huh.
There's some water, it's dripping over here.
Let me see. I think what it is we didn't even put enough water in there. Oh yeah, it's still going. I can kind of see it.
Yeah. Wow. It's
Can you guys
already
see
at 40 seconds.
It's going through. It's moving.
Mm-hmm.
What did you do in class today? Well, me and Mr. Dalday watched water go through sand.
It's actually kind of going a little sideways.
Yeah, it's interesting. It's actually...
Sideways.
Now, I'm trying not to shake it as much as possible, because what would happen if I did this one, I just poured it in, this one, I put it in, and I shaked it like this?
It's already at a minute.
All right, it's already at a minute, but it's going. It's still going. I think the thing is we didn't put enough water.
In the test tube?
Yeah, but this is a good experiment. We'll see. Okay.
Almost there.
And I would say stop.
1 minute and 31 seconds.
1 minute, 31 seconds.
That was B.
That was B.
1 minute and
All right. Let's do the clay.
1 minute and 31 seconds.
All right, let's do this. Now, I'm tempted to put 20 milliliters of water in here because, you know, I mean, I didn't put enough water, so I mean, I think that that's kind of what happened.
We could do it, so we could put 20 milliliters, and then if it just doesn't go right, we could empty that out and put it again, and then try 10 milliliters.
Why can't I just try 20 right now?
You could.
No, I can't. Because what that's doing is you did 10 milliliters with this one,
Oh.
10 milliliters with this one, and you did 20 over here. You're messing up your control variable. So the amount of water that we start off with should be a control.
Mm-hmm.
So we should try to keep everything the same, every parameter the same. Even though in the future, if I do this experiment, I'm going to use 20. Okay, ready?
3, 2, 1, start.
All right, you can kind of see it over there on the camera.
Yeah. This is actually going faster.
Is it going faster?
It looks faster.
I don't know.
You can see over here
Can you see it?
on the camera.
Yeah, I can see the camera.
It's going down for faster.
All right. Well, let's wait then.
Yeah. Okay. So imagine D with the sand and the clay.
You think it's gonna take longer or shorter?
Yeah, I think it's gonna take longer because it's sand and the clay. And
I'll tell you what. You know what? We got another stopwatch. We can keep this stopwatch going right here. Just move this right here.
Yeah.
Put this like right here.
It's already.
There we go. Now you can see it. All right. And then what we'll do is we'll use the other stopwatch, and we'll kind of do this one. It's not really an exact race because if it were, I wanted to race them, I would pour 2 at a time. But we've got another stopwatch. We can actually have 2 experiments running at the same time. All right. Let's see. Whoa! Don't bump the table. All right. 10 milliliters. Here we go.
3.
Hey, wait. All right. You ready?
2. 1. Go. Oh, wow.
Well, it went through the sand really fast.
Yeah. And the clay is the longest.
What was the sand? 1 minute 31 seconds?
Yeah. This is already way past.
This is already 1:50 seconds.
About 2 minutes.
I don't even think it's ever going to make it. To be honest with you, it's only gone this far down.
And this one hasn't even really touched the clay.
Well, no, it looks like it's touching the
Really?
clay. It's penetrating the clay.
Really? I can never see it.
Can you see it? That's interesting.
And then there's like a whole bunch of water up here.
So the clay is like the ultimate stopper.
Yeah. So there's like a whole bunch of water right here, and the sand is stop. I think because the clay.
You can see it better that way.
Yeah, I think the clay. It's because it's stopping all the water from going.
But you can even
Below
look.
the
Look.
sand.
Which one penetrated more? Which one did the water go down further?
Then let's say D, because of the sand. It went like.
This one, I don't even know if it's ever going to make it.
There's still some water up here. Just doesn't go down.
Yeah, there's water in there. Kind of see it.
How much is that one?
See the water up there?
Yeah.
We're at 3 minutes already.
This one's at 1 minute and 40 seconds.
Yeah, so this one has a better chance of getting to the bottom than this one.
Yeah.
I don't even know if that thing's going to ever make it, to be honest with you. I think all of your water will evaporate by the time that thing makes it to the bottom. So, here's the conclusion that we came up with. Based off of our experiment, and actually, you know what I'm going to do is I'm going to ask you to put, for the actual time, for the clay thing, I'm going to have you put, for the clay, I'm just going to have you put, I'll write a note on the bottom, say NA or something like that. And then explain what that note means. NA is not applicable. Why couldn't we measure the time it takes for the water to get to the bottom?
Because it wouldn't go to the bottom.
Because it's so tightly packed in there that it won't ever go to the bottom.
I think this one is exactly the same. But wouldn't those two be like the same then if they both won't go to the bottom?
Yeah, you're gonna have to say NA. I mean, our experiment doesn't work at this point.
Wow. It's not even going anymore.
Oh, this one is kind of moving.
It is?
Yeah, I think I put way too much of the sand stuff inside here.
So do you want me to write NA for you?
Yeah, you need to put NA and you need to explain what you did and why it's not applicable, why you couldn't measure it.
And then for both of them, I would write the clay stopped it.
Well, yeah, write down your observations. So you observe that you can't even measure it because it's so slow. It's so slow that it's actually longer than our video. How's that? That we're recording. So I'll tell you what, we'll just let this thing keep on going, and I will post the answer for if this thing ever reaches to the bottom. I'll just let the stopwatch keep on timing it. Sound good?
Yeah.
Well, for those of you online, If it doesn't sound good to you, tough, because that's the only option you got.
That's already at 5 minutes.
Yeah, we're at 5 minutes already. All right, so that's our experiments. Hope you like it. You can use this data to fill in all that information.